There we go. Um, so I want to talk about a little bit about what we're doing with KeystoneREN. KeystoneREN is a statewide research and education network for the state of Pennsylvania. We provide connectivity to Internet 2 out of the Philadelphia and the Pittsburgh locations. One of the things we want to talk about today is really understanding, what when you're working with and how you're accessing national facilities through your state campus and state networks and how you connect to the national backbones. One of the pieces we get into with is really understanding the data transfer speeds and things like that to get your data to and from the resources you're looking at. One of the models around that is called a Science DMZ. So we create a network that is a friction-free path to move your data to really anywhere in the country, anywhere in the world. And there are a couple components to that. And one of the pieces is really understanding where the network piece comes into play to make sure the data can be moved to and from locations. In addition to that, there are also servers called data transfer nodes. These are specifically tuned systems to be able to move data back and forth between locations. The third piece with that would be a testing node to make sure that we are testing the most appropriate speeds we can get on these pieces, as well as we talk about an engagement with the end users. So this slide really talks about, we may design it a certain way, but the user experience may be completely different. So that's what we actually try to do through the engagement piece on this. We want to make sure researchers have access to resources available and what they can to be able to complete their work, but we want to make sure we can do it in a secure and as well in an expedient manner. So this is a bar just from ESNet. The piece around this too is building a data-centric narrative around what we're trying to do with related to networking to connect to national resources. And so if we start focusing everything around the data, all the other components really become kind of the legs of the stool, if you will, as we talk about these different pieces. So the network is one piece of that. Some people call it the cardiovasculatory system of all research workflows. As you connect out to either a resource facility or a compute center storage or even what software and algorithms you're using. One of the pieces that comes into play is when you start moving data around the current world, one of the little bit further away you get, data performance and data transfer performance can drop extensively, moving a little bit outside of your campus. So if you're having any sort of major issues with data transfers and piece like that, the further away you are, the worse it can get. So this is something we want to address with making sure that your network is capable of transferring data. This is a model and design we talked about related to moving data efficiently. This is one of the things we can do with campuses to take a look at this and ties to the national connections. As we get into this, the data transfer scorecard is really what I want to talk about. The idea here, if you're not moving, have the ability to move 1 terabyte per hour, that's something else you can work on with this related to this. That turns into 2.2 gigabits a second on a network. And so related to this, a lot of people have a difficult time transferring data, even at a terabit level. And one of the things we can do with that is really just understanding what we can do to help move that data more efficiently to and from the access centers and things like that from a campus level. So that's part of these pieces that come into play. Other resources out there, there's actually a couple dashboards that you actually try to see your data to and from your campus to the actual access facility. So this is something else related to network performance. You can actually see the data and understand how much data is being transmitted, what time and what time frame, as well as how well it's performing. And again, if it's below the rate on the data transfer scorecard, that's something else you can go into. So another piece is if you're transferring data with the Globus tool, what you can do is actually understand there's a dashboard now that you can actually see your data transfers to and from Globus, or using Globus to and from a source and destination related to this. So a lot of this log data is really understood. So you can actually have a dashboard related to how well your transfers are performing. And if you're having any issues with that, a lot of times you can reach out to your campus network or your research network across your state, or even contacting the national backbone. But there's also other NSF-funded facilities to be able to understand if you are having data transfer performance to and from access facilities related to this. So these are two different couple links here you can actually look at for this. So, and that's what I had on network performance. So.
Great. Thank you so much, Ken. And speaking of Access and Pittsburgh Supercomputing Center, I am now very happy to introduce our next speaker, Stephen Deems. Stephen Welcome, welcome. Stephen is the Director of Strategic Initiatives at the Pittsburgh Supercomputing Center, and he has over a decade of experience working directly with the research, computing, and educational communities that PSC serves. Stephen's going to tell you all about the Access Project and some of the resources that are available through the work that he's involved with on the RAMPS initiative. So, Stephen, welcome.
Thank you, Jennifer. Thank you, Ken, for having me. Um, I'm going to drop my slides in the chat in case anybody wants to skip ahead, maybe you've seen some of this before, knows some of the content. But I am going to talk pretty much about three different levels. I'll talk about, very insular at PSC and some of our initiatives happening across the state. But I think the majority of my talk is going to be about what's available at the federal level for any US-based investigator. So again, just that was my quick highlight. We will talk about the ACCESS program along with another federal pilot called the National Artificial Intelligence Research Resource Pilot Program. So just PSC at a glance for those of you that haven't heard of us. We're an advanced cyber infrastructure provider, research collaborator, and we provide also training, user support, assistance with using cyber infrastructure, transferring data, things like that for the local community, national research community, government, industry, nonprofits. I'm going to talk a lot about CI, so I won't unpack that here, but on the research collaboration side, we're pretty big on data sciences and health sciences. So we have a lot of active projects in that space in the National Institutes of Health realm. Again, talked about training, user services. But PSC actually resides within Carnegie Mellon University, within the Mellon College of Science. We're also partnering with the University of Pittsburgh. We're founded by a Pitt professor over there. We're mainly funded by federal and state support. Our systems are available around the clock, but for any user assistance scientific support, it's typically within normal business hours. But PSC also operates a regional optical network, which some of y'all may be familiar with, called 3 Rocks. So again, at PSC, since we rely mainly on federal funding for this work, a lot of what we do happens at the national scale. And when I'm talking to extremely diverse audiences, I always want to make sure I pause and talk about cyber infrastructure, what it is, how it is, and actually wouldn't exist if there weren't for people powering this. So from the data center where a lot of this equipment resides, there are plenty of diverse job titles and backgrounds and experiences required to even just power things, let alone the networking staff, operations, security, folks to keep track of accounting on these systems, how many gigabytes are being used or terabytes being used, performance data, scientific support, user support. And then you start getting into this realm of blurring this vision or blurring this line of technical versus cyber infrastructure, where we need people who know how to communicate about these things. We need people who understand the project, the scope, and can carry out execution of it, as well as the folks involved in education, training, workforce development. And even at PSC, we're employing plenty of librarians who are helping to curate and manage data sets. So moving away from, these are the people that assist, I want to talk about what is actually available at the federal level. So this is really nothing new in terms of what is available to the community. These types of projects have been around even since the 80s and 90s, but here are the most recent iterations of what's available provided by the National Science Foundation. So the ACCESS program, which I'm a part of a lead of, is not anything new, just some of the ways that we've tweaked the program are a little bit different. And ACCESS, like many federally funded projects, is an acronym, and it stands for Advanced Cyber Infrastructure, ranging from anything from I need to scale a little bit beyond the hardware that I'm working on right now in my lab, all the way to I need to run across multiple racks within a data center for really large simulations. This coordination ecosystem piece is ACCESS that is actually a collection of awards, separate cooperative agreements working together to fulfill the mission. So the team that I'm a part of, the team I'm presenting on behalf of, is the team that gets researchers and educators onto the cyber infrastructure. And finally, the last two pieces, just the services and support, which I'll detail now. For folks that are wondering, when do when do I outgrow my laptop? What does that mean? This could range from, hey, this is running really slow on my machine. My professor told me it should take a couple minutes, it's taking a few hours. If your screen and your machine regularly freezes up, or when you no longer have space to even load some data onto your machine, you may want to start thinking about what's available at the national level. So as I just mentioned, the job that our team has to carry out is connecting the communities to these resources for whatever purpose that they may need to use them for. Our vision in the project and in ACCESS and what we changed from the past couple of programs is we want to make sure that no matter what institution you're at in the United States, what field of science you're in, your individual demographics, like you can get on to these resources. So we want to continually improve that process, those offerings, to make sure that anybody who wants to try these out can get on. And as your needs grow, if you need hundreds of thousands of GPU hours a year, the justification that you provide has to increase with that as well. So those that need just a little bit of a very smaller barrier of entry onto the systems. And the major product that our team develops is the software to handle accepting these proposals, reviewing them, administering accounts, adding users, accounting, etc. So that's the big focus of our program is on software development for these processes. Now, what's available in ACCESS ranges from different CPU architectures, various core counts, memory sizes, as well as NSF-funded cloud resources. So they actually have an on-prem cloud resource. This isn't AWS, Azure, or Google Cloud, although that is available through other NSF programs. Various types of accelerators are available, probably the most common being GPUs. So many different flavors of GPUs are available, but also some more novel architectures like vector processors or FPGAs. There's different types of data, whether it's on tape, flashed, different tiers, object storage, but as well as things that are moving away from the hardware, like common data sets, software or workflow managers, as well as, especially for this community, high performance networking. Again, can't forget the people who help support this in the scientific realm, user support side, as well as systems monitoring. On the right-hand side, you'll see a link to all of the different resources that are available. You can explore a lot of the technical specs about them, see if they have any upcoming trainings, a lot to explore in that new catalog. It was just released in December. So if you have any feedback on that, you can contact me after for suggestions on how we can improve that offering. One thing that's relevant to a lot of the scientific audiences that we talk about is there's quite likely a scientific gateway in your field of science currently operating under ACCESS. So we have over 40 different domains or different gateways represented right now across multiple domains. So you can check that out. But the process of getting on, like I noted earlier, it should be very simple for folks who are new. So you'll see some metrics on how we're actually performing on this in a little bit. But essentially, as your needs for CPU hours, GPU hours, even terabytes of storage increase, the amount of justification that you need to provide for that increases. So with nothing more than 3 or 4 sentences about who you are, what you're looking to do on these resources, we can get you onto the system. As those needs grow, we ask you for a page of justification, then 3 pages, and then finally, a 10-page request where this is getting into the order of hundreds of thousands of dollars in the actual cost to operate that level of allocation. So who can get on? If you are at a US-based institution and you are at least a graduate student, you can request and lead your own project. If you are a researcher that has multiple supporting grants and funded research, you can request multiple projects. I talked a little bit about the page links already, but again, this is really emphasizing on make sure people can get in and get started and grow if they need to as well. Everything available in ACCESS is absolutely free of cost. You will never, be sent a bill or asked for any sort of donation for this. This is made possible by federal tax dollars. You do not need a supporting grant. I think that's one of the kind of misnomers we're trying to shoot down is as if you are trying to explore an idea, project, you're welcome in Access. So I talked a little bit about speeding the process up, talking about making sure that people get in. We're coming up on our refresh numbers for 2024 when we submit our annual report in a couple months. But from the start of Access in 2022 to last year in 2023, we reduced what we call the ecosystem access time. And this is essentially clocking from the time someone starts a proposal submission saying, I want to use these systems, and the clock ends when they run their first job and we get the accounting data back from the system. So last year, we're averaging just about 10 days to go from submission to actually using these resources. For those that are interested in getting their own project, you can save this slide and follow the instructions here. It's pretty simple. Get an Access ID, request that project type that you think is best for your needs. If you know you need a little bit more than the starter level allocation, you can request that from the start. You can also add co-investigators, allocation managers to handle adding, removing users, requesting resources. And once you're approved, you start picking the various resources that are applicable for your interests. I'm going to go through science highlights really briefly and just say there's any field of science that you can think of likely has a potential use for cyber infrastructure. Some of the things in these slides are hinting at a lot of stuff we're seeing in the news in terms of detecting deep fakes, a lot of machine learning, AI related work. But these allocations are also being used in coursework and making sure that students at the undergrad or graduate level are having hands-on experiences with this and also putting them toward real world applications like the one on the top here about real-time irrigation of crops. So a professor at Prairie View has built a web-based tool, is running it on Access resources to make it scalable for their classroom. Again, a lot of extreme events in weather is prevalent in the news. We see it all the time. So this is just to illustrate there's a huge breadth of research happening on Access. In terms of who's actually here and represented, as you can see, very, very heavy on the East Coast. I believe we have allocations in 48 or 49 states. This map's probably a little bit out of date as well. You can explore the map, check your specific geographic region, read about some of the projects that are leveraging Access. So this was a slide from our review last year to demonstrate this is how many fields of science are actively computing here, but a little bit about the makeup of our community. So about 1 in 4 Access users indicate or identify as female. And actually, surprisingly, in this data, we saw that about 1 in 3 researchers in Access is coming from a non-R1 institution like Carnegie Mellon, University of Pittsburgh, University of Pennsylvania. So this was pretty eye-opening for us, and we like to attribute it to the fact that it's much easier to get in now because we really haven't targeted efforts in this area yet. But it was really great to see this data and start thinking about where can we go next and where's the most need. So if you find yourself at Access, you find yourself interested, but you don't really know where to go next, or maybe you have some questions that are specific to your lab or specific to your job title, reach out to us through the ticket system. You will need to create an Access ID that should take no more than 5 minutes. You can interact with our Q&A bot that's trained on all of our policies and all of our documentation that may be able to help you. You can reach out to some of these computational resource providers directly, such as myself at PSC or one of our staff. Or again, I invite you to just drop me an email. You'll see that on the last slide. But reach out and we can set up a call if needed. The one plug I have for you all today, and I want to give a shout out to Jennifer. Had I had a little bit more time, I would have updated the KeystoneREN slide. But the team that I'm a part of, we have what we call an innovative pilot, or what the NSF calls an innovative pilot, that we had to bring some ideas for how are we going to broaden the community, bring more people into the ACCESS program. And we thought rather than trying to bring people to ACCESS, let's bring access to them. So the resource catalog that I showed earlier is actually an embeddable web widget. It's no more than 20 lines of JavaScript that you can plug into either your campus institutional web pages or your organization if you're a part of one, or even a for-profit entity. So this was one of the things that, hey, we'll see how this goes, see if people are interested. We just launched a couple weeks ago. We have 7 of them currently in operation. They're very easy to set up. If you're interested in more, Jen can probably even talk to you about her experiences in setting these up. But there's a link to check out more if you're interested in that. You can also reach out to me directly. So that's it for the ACCESS program. I'll talk about something that's very similar, a little bit different, a little more high level. But this what everyone's been referring to as the NAIRR, the National AI Research Resource, initially came out of a task force that was established back in 2020. The task force met for about a year and a half. And they released a final report with recommendations for how the U.S. can better position itself to lead and continue leading in the field of artificial intelligence. Last October, I guess 2 Octobers ago now with the new year, the Biden administration issued an executive order to launch a pilot program based on existing resources in the community for AI related research and education. So this not only includes the resources that are available through the ACCESS program, especially the GPU resources that are available, but it includes many private sector partners that you'll see listed here. Some of them are in very novel architectures, some are focusing more in education and training, and some of these are the major cloud vendors and OEMs that you're probably familiar with. So in terms of the diversity of resources available, the NAIRR pilot has a much more diverse set of resources than the ACCESS program. The allocations process is a little bit longer, or at least the time frame to get an allocation is much longer than 10 days. I think we're getting down to closer toward 2 months from submission, review, approval, and onboarding. But this is a 3-page request. You can see all the information at nairpilot.org. But some of the policies are different here is that you must be computing in the US. In ACCESS, you have to have a US-based lead, but if you go overseas, you will not be able to compute in NAIRR pilot. And from the research community, we've been getting this question a lot is, well, which one do I choose, ACCESS or NAIRR? So this is how I've broken it down, is that if you have very long-term research needs that you expect for years and years, go to ACCESS. And the other caveat there, the other consideration is this is for all types of research, whereas NAIRR is strictly for AI-focused projects, and they're also looking for very short-term success within NAIRR pilot. We approve most of our requests in ACCESS in just about 1 business day. So 83% of requests, you're going to hear back within 24 hours of your submission. After you get approval, you then request resources to run on, and that typically takes about 3 days to get an account on an actual system where you can log in. But as you can see on the right, we're taking a much longer time on the NAIRR pilot side. We've crested over 300 submissions since this launched last January. So we're seeing a bit more demand than we thought we'd see. So this is my last slide is a little bit more content on some PSC related initiatives. So we talked a lot about CI. Let's talk a little bit about maybe there's some institutions, campuses out there that want to leverage this and want to put it into their curriculum, but they can't just make that leap on their own. And that's where the ADAPT PA program comes in at PSC. So we currently have partners scattered across Pennsylvania, working to modify, enhance, interject some data analytics, data science, and just computer science into their existing coursework. So this is also free of cost to participate. Megan Carroll's the lead of this, so if you want to reach out to Megan, she'll be able to give you a lot more detailed information than I can provide. So I don't really have a summary slide. I just wanted to say again, thank you to Jennifer and Ken for inviting me here. I'd be happy to come back if needed. And I only see one thing in the chat, which I'm poking at right now. But I'd be happy to take any questions or comments or even feedback from those that are familiar with the program. But yeah, thank you all very much.
Thank you so much, Stephen, and thank you, Ken, for your session. I wanted to open it up for interactive questions. If people, we have a small enough group here, I'm comfortable with that. If people want to unmute and ask your question, please feel free. Otherwise, of course, put it in the chat or comments, feedback. Happy to entertain that now. Make sure I'm not hard muting everyone and that they can't actually unmute even though they have a burning question. So I'll just check on that as well.
They're probably busy digging through all the links in my slides. So sorry, go ahead, Eric.
Yeah, I guess I'll start, and I apologize for probably asking the really stupid questions. I'm coming from a non-R1 school here, and when you listed, sort of the access available things, went there immediately. I'm an ex-computational chemist, so I immediately went to the chemistry ones, and they're all focused around undergraduate, access to computational resources for undergraduates, which is great, which is actually what we're looking for. And is there a different process for something where you're looking at a non-research based, fully undergrad, simply, we want people to have some experience doing these types of projects in undergraduate work. We know we're going to need it, not for 1 or 2 years, but this is the sort of thing we'd want to keep rolling. Is that structured differently than it would be for, somebody who's using it for research?
Well, first off, I'll say not a stupid question. Very good question. It was something I could have hit on a little bit more. The project types are designed for the most flexibility. So for a use case like that, I would say same process applies. Give us a couple sentences. You can come back and renew that allocation year after year as needed. And that's me suspecting that you won't need that high of resources, or like in terms of core hours, GPU hours, things like that. But yeah, the framework that we have for requesting a project is an attempt to be that it's really just based on what do you need. And if you don't know what you need, we always request people start small and we can help you upgrade over time. But yeah, this is a fine use case. And the same thing for like a coursework based allocation where a professor might be instructing undergrads or graduates every semester. They can request a project for every class, or they can just have one that they continually use and repopulate. So it's highly flexible to the needs of whoever's on the other end.
Yeah, our use case would probably be one professor. He's the one who does both sort of, the general and upper division PChem classes. But we're talking, probably far smaller allocations than our normal, we'd be looking at maybe like a dozen undergrads at a time, throwing jobs that might take, an hour or two at most. Yeah.
Yeah. So that's, I'd say the first project type, which is called Explore, will be perfect for that. Again, just a couple sentences about, that maybe if you knew the software package, it sounds like the software package you want to use. Just, hey, this is what we plan to do. This is who might use it. You'll hear back within a day from us.
All right, thanks.
Yeah. The other thing I failed to highlight in the slides, or maybe I'll have to go back and see if it's in there. 95% of our requests are approved. Out of those 5% that aren't approved, what can occasionally happen is maybe they request a project type with really, really high resource needs, and it goes to peer review, and a reviewer says, hey, I haven't seen any usage from your group yet. Why don't you start a little bit lower, show some progress, and then come back for more? So anybody who is denied is either ineligible, potentially undergraduate level, or based outside of the US, or they're realigned with another project type. So do not fear that your request will be denied.
Thanks, Eric. Thanks, Stephen. Other questions, comments? I know we've got a small group left on the call, so maybe folks have dropped off for their 11:30s already, but I want to just give space there if there are any additional final thoughts or comments. If not, I will end the recording and